Good morning, dear students. Today's topic is pin diagram of 8051 microcontroller. 8051 microcontroller has 4 ports. On reset, all these 4 ports are configured as output ports. If you want to configure them as the input ports, you need to program them. Means on reset all the ports are acting as the output ports. If you want to make them as the input port, you have to program them. Among these 4 ports, one port is exclusively available for the function of input-output operation for the programmer. That port is nothing but port 1. Port 1 is assigned starting from the pin number 1 up to pin number 8. That is, pin number 1 is port 1.0, pin number 2 is port 1.1 in the similar way, and so on up to pin number 8, that is port 1.7. This particular port is exclusively available for the input-output operation for the programmer, whereas the remaining 3 ports, that is port 0, port 2 as well as the port 3, they are assigned with additional functionalities. What are the additional functionalities that are assigned to these 3 ports? Let us discuss one by one. Port 0. Port 0 is started with the pin number 39. Pin number 39 is nothing but port 0.0. Pin number 38 is nothing but port 0.1, and so on up to pin number 32, that is port 0.7. This particular port 0 has the additional function, that is, it is acting as the address data bus. Means lower order address bus of the 8051, that is A0 to A7, is merged with the data bus. That is why it is called as address data bus. So therefore port 0 is acting as the address data bus, that is AD0 to AD7. If you come to the port 2, this port 2 has the additional function, that is, it is acting as the higher order address bus, that is A8 to A15. 8051 microcontroller is a 8-bit microcontroller, so therefore it has the 8-bit of data bus, that is D0 to D7, which is merged with the lower order address bus of 8051, whereas higher order address bus, that is A8 to A15, which is the additional function of the port 2. The port 2 is started from the pin number 21, that is port 2.0, pin number 22 is port 2.1, and so on. Pin number 28 is port 2.7. This particular port is assigned with additional function, that is, it is acting as the higher order address bus. Now let us move on to the next port, that is port 3, which is starting from the pin number 10. Pin number 10 is nothing but port 3.0, whereas pin number 11 is port 3.1, and so on up to pin number 17, that is port 3.7. Now let us consider the pins 10 as well as the 11, which is port 3.0 as well as the 3.1. These 2 port pins are having the additional function. One pin, that is port 3.0, has the additional function of RxD, that is receive data, whereas port 3.1 has the additional function TXD, that is transmit data. These two pins are used for serial communication purpose. 8051 microcontroller has one serial communication unit inside it. In communication, there exist two types of communication: parallel communication as well as the serial communication. These two types of communications are going to have their own advantages as well as the disadvantages. We will discuss it later. 8051 has the serial communication unit for which two pins are reserved, that is pin number 10 as well as the pin number 11. 8051 transmits the data serially to the peripheral devices through the pin number 11, that is through pin number 3.1, that is TXD. TXD stands for transmit data serially to the peripheral device. In the similar way, if the 8051 want to receive the data serially from the peripheral terminal, then it will do so on the pin number 10, that is port 3.0, that is RxD pin. RxD is nothing but receive data serially from the peripheral device. Next, pin number 12 and 13. Pin number 12 is port 3.2, whereas pin number 13 is port 3.3. They are the interrupt pins. INT 0 bar is the additional function of port 3.2. INT 1 bar is the additional function of port 3.3. These are the two external interrupts of 8051 microcontroller. 8051 microcontroller has 6 interrupt sources. Among them, 4 are the internal interrupt sources, whereas 2 are the external interrupt sources. External interrupts can be accessed on these two pins, that is on pin number 12 as well as on pin number 13. These two pins are the input pins and they are the active low signals. They are the interrupt pins. INT 0 bar, active low signal. INT 1 bar, active low signal. They are the input pins, interrupt pins. That is, external interrupts are received on these two pins. Next, pin number 14 as well as the pin number 15. Pin number 14 is nothing but port 3.4 T0. Pin number 15 is port 3.5, that is T1. 8051 microcontroller has two timer units, timer 0, timer 1. They are 16-bit timers. Two timer units 8051 microcontroller has. These timers are going to act as timers as well as the counters. Whenever these timer units acts as the timer, they are going to receive the clock signal from the internal clock circuitry. Whereas if these two timers, if they are acting as the counter, in that case they are going to receive the clock signal from the external sources. Hence, for that purpose, these two pins are provided, that is pin number 16 will receive the pin number 14. Pin number 14 is reserved for timer 0 to receive the external clock signal in P3.4. In the similar way, external clock signal will be received for timer unit 1 on the pin number 15, that is port 3.5. These two signals are input pins, means the signals are coming into the 8051 microcontroller. They are the input signals. Pin number 16 as well as the 17. Pin number 16 is nothing but port 3.6. It is the write bar signal, whereas pin number 17 is port 3.7. That is the read bar signal. In a computer system, we frequently have two types of operation. One is the read operation, another one is the write operation. Read operation is nothing but whenever the microcontroller want to fetch the data from the peripheral device, that it will do so on generating the read bar signal. So read bar signal is the output signal which is generated from the 8051 during read operation. What is the read operation? Read operation is nothing but fetching the data from the peripheral devices into the 8051. In the similar way, one more activity which is frequently happening is that the write operation. What is the write operation? Write operation is nothing but sending the data from the microcontroller, that is 8051, to the peripheral devices. During that time, 8051 microcontroller will generate the signal, that is write bar, WR bar signal. Is a active low signal. This signal will be generated from the 8051 during the write operation. What is the write operation? Write operation is nothing but whenever 8051 want to send the data to the peripheral device, during that time 8051 microcontroller will generate the write bar signal. So therefore these two signals, write bar as well as the read bar signals, are the output signals, means they are generated from the 8051 and they are sent to the peripheral devices. These are the additional functions that are allocated to the port 3. Now let us discuss the remaining pins of 8051. Pin number 18 as well as the pin number 19. Pin number 18 as well as the pin number 19, they are reserved for the oscillator inputs. Every activity in 8051 will happen in a time-bound manner. That facility will be made available by generating the clock signal. Crystal oscillator will generate the clock signal. That signal will be supplied to these two pins. So these pins, pin number 18 as well as the pin number 19, they are reserved for getting the clock signal from the crystal oscillator. What is the usage of receiving the clock signal? As I already told you, all the activities that are happening in 8051 environment, they are happening so in a time-bound manner, for which we need a clock signal. That clock signal will be generated from the crystal oscillator and they are supplied through these pins, that is pin number 18 as well as the pin number 19. Pin number 20 as well as the pin number 40, they are the power supply pins. Plus 5 volts of power supply will be applied to the 8051 IC through this particular pin, that is pin number 40 will be connected to plus 5 volts of power supply, whereas pin number 20 is circuit ground, is connected to the ground potential. So hence these pins are known to be power supply pins, pin number 40 as well as the pin number 20. Now let us come to other pins. That is pin number 29 is PSEN bar. PSEN bar is nothing but program store enable. It is an output signal, output active low signal, which is generated by 8051 during external program access. Means whenever 8051 access the program from the external program memory, so 8051 is going to interact with the two type of memories. One is the data memory, another one is the program memory. So 8051 has the internal program memory as well as the internal data memory.